You know that feeling, right? You're in a crowded stadium, a busy city center, and suddenly your phone's internet just crawls. It's a classic problem. Too many people, not enough bandwidth. The real challenge for any network is how to serve everyone at once without the whole thing grinding to a halt. Well, today we're going to pull back the curtain on a technology called MIMO. It's kind of the unsung hero that keeps our digital world connected. So how does it work its magic? Now, MIMO, that's multiple input, multiple output, can do a lot of things. But its real genius, especially in a network environment, is its ability to serve many different people simultaneously. See, it's not just about giving one person a faster connection, it's about lifting up the performance of the entire network for everyone on it. And this is where a specific flavor of the tech, known as multi-user MIMO, really comes into play.
Okay, so multi-user MIMO, or MU-MIMO. The concept is actually pretty simple. The magic is right there in those two words, multiple users and simultaneously. Instead of making all our devices wait in line and take turns grabbing data, which, creates lag, the system serves them all at the exact same time. But with all those signals flying around, how does it keep everything from becoming a chaotic mess?
Well, the answer comes down to a really clever principle called space division multiple access, or SDMA. Think about it like this. The system doesn't just see a random crowd of phones. It sees each device in its own unique spot, and it uses that physical space to create separate, invisible data highways for each user. It literally turns chaos into clean, orderly lanes of traffic.
So how does it make these invisible highways in midair? This is the really cool part. It uses a technique called beamforming. So instead of a cell tower just blasting a signal out in every direction like a giant floodlight, which would cause a ton of interference, it acts more like a series of super precise spotlights. It forms these narrow, focused beams of data aimed directly at your device while carefully avoiding everyone else's.
Now, this isn't some far-off futuristic concept. This is the engine running under the hood of our wireless world right now. In fact, you're probably benefiting from it as we speak. So let's look at its biggest, most important real-world application. Yep, we are talking about 5G. All those revolutionary speeds and the incredible capacity that 5G promises, a huge part of that is thanks to a scaled-up, supercharged version of this exact technology called massive MIMO.
This image here gives you a great idea of what's happening. Those 5G towers you see, they are packed with hundreds of tiny antennas, all working together. That is massive MIMO in action. It's creating this incredibly complex web of dedicated data beams, shooting them out to tons of different users all at the same time. It's pretty amazing.
Okay, so that's a lot of tech talk, but what does all this complexity actually mean for you and your phone? Well, it really boils down to two game-changing benefits: a massive boost in network capacity and a huge leap forward in efficiency. Let's break these down. More capacity? That's simple. It means the network can handle way more users without breaking a sweat. No more digital traffic jams. And spectral efficiency? That's just a fancy way of saying we get a lot more data out of the same airwaves we've always had. For you, the bottom line is a faster, more stable connection, especially when you're packed in with tons of other people in a busy city. And this quote just nails it. This technology was designed from the ground up to solve the problem of digital density. It's all about making a network that works just as well in a packed concert as it does when you're home alone. It's a network that's actually built for the crowd.
So the next time you're in a crowd and your 5G connection is still lightning fast, you'll know exactly why. It's that invisible, intelligent dance of data beams from a massive MIMO system working hard behind the scenes. This technique really is the difference between a network that just struggles with demand and one that was built to thrive on it. So what other unseen technologies do you think will shape our connected future?